Hello students, we are solving the IB Math AHL past paper questions and currently we are solving the IB Math AHL May 2023 paper 1 time zone 1 past paper. Today we will be solving the question number 10 of this paper. Actually this is a common question common for both the SL and the HL students. For the SL students it is question number 8 and for the HL students it is question number 10. And for the HL students you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering this question. The maximum mark is 14. It says, consider the arithmetic sequence U1, U2, U3 and all. Sum of the first n terms of this sequence is given by Sn equal to n squared plus 4n. Subpart A is having two further subparts. The subpart I, the first subpart of subpart A is saying, find the sum of the first 5 terms. N stands for the number of terms. Sum of the first n terms. So Sn is the sum total of the first n terms. And we are required to give the sum total of the first 5 terms. So n will be equal to 5. So it should be S5 equal to n square, which is 5 square, plus 4n, that means 4 times 5. And 5 square is 25 plus 5 times 4 is 20. So this is equal to 45. Okay. Coming to the second subpart, I given that is 6 equal to 60, find U6. That means the sixth term. Okay. And Sn is the sum total of the first n terms. So what will be the sum total of first one term? It will be equal to S1. Okay. And this will be equal to 1 square and plus 4 times 1. So 1 square is 1 and 4 times 1 is 4. So 1 plus 4 will be 5. This is equal to U1. Okay. Because it is the sum total of first one term. And what is the sum total of first two terms? It is S2. So n is 2. Therefore 2 square plus 4 times 2. 2 square is 4 and 4 times 2 is 8. 4 plus 8 is 12. So this will be equal to U1 plus U2. Okay. Now, if we have to find the second term, because over here we are asked to get the sixth term and we are given the sum total of the first 6 terms. Okay. So that is why I am taking this example. Okay. So S2 equal to U1 plus U2 and S1 equal to U1. So if we want to get the value of U2, the second term, we can do S2 minus S1. S2 equal to U1 plus U2 and S1 equal to U1. So minus U1. These two will be getting cancelled and we will be having U2, which is the second term. So we can get the second term by subtracting S1 from S2. Okay. So in order to get U6, we should be subtracting S5 from S6 because this is the second subpart II. S6 is equal to U1 plus U2 plus U3 plus U4 plus U5 plus U6. And S5 is equal to U1 plus U2 plus U3 plus U4 plus U5. Okay. So if we subtract S5 from S6, we should be getting U6 because U6 is the only additional term that we are having in S6. The remaining terms are present in S5. Okay. So U6 will be equal to S6 minus S5. S6 is equal to 60 minus S5 equal to 45. So therefore U6 equal to 60 minus 45 is 15. So U6 is equal to 15. Okay. Find U1. Okay, we have already found the value of U1, but in any case, I have to write the answer for the subpart B. So it is S1 is equal to 1 square plus 4 times 1 equal to U1 equal to 5. Okay. So we now come to the subpart C. Fine. Let me start over here. Hence or otherwise, write an expression for UN in terms of N. Okay, in terms of N. So what we know about UN, what is the general formula for any general term of an arithmetic sequence? It is equal to U1 plus N minus 1 times T. Okay, we know the value of U1, but we do not know the value of D. So first of all, we have to find the value of D. And I have actually found the value of U2 over here. But let me find it once more. So because I need the value of D, the common difference. So it is 2 is equal to, it is N squared plus 4 times N. Okay, you can see the, okay, or else I can show you the formula once more. N square plus 4 times N, and N is 2 for S2. So it is 2 square plus 4 times 2, 4, 2 square is 4 plus 8 is 12, and U2 is equal to S2 minus S1 is equal to 12 minus 5, which is equal to 7. Therefore, D is equal to U2 minus U1, which is 7 minus 5, that is equal to 2. Okay, so we have got the value of D. Therefore, I can write this. I have to start over here. UN equal to U1 is 5. Okay, plus N minus 1 times 2. You may keep it in this way. As your final answer, you can give this expression and you will be getting full marks, or else you can write this as 5 plus 2n minus 2, which is equal to 3 plus 2n. Okay, so this is the answer for the subpart C. Fine. And now I have to leave this portion and I have to start answering the subpart D. The question is, consider a geometric sequence Vn where V2 equal to U1 and V4 equal to U6. Okay, subpart D's question is, find the possible values of the common ratio R. It is containing 3 marks. Okay, let me write the subpart D's answer over here. Okay, so V2 equal to U1. V2 should be equal to V1 times R. V1 is the first term of the geometric sequence and R is the common ratio. This should be equal to U1, which is equal to 5. Okay, so let this equation be numbered as 1, and V4 should be equal to V1 R to the power of 3 equal to U6. What is U6? U6 is 15. Okay, this equation is numbered as 2 and we are required to get the value of R. Therefore, we are dividing equation 2 by equation 1. Okay, so it is V1 R cube over V1 R should be equal to 15 over 5, which is equal to 3. And these two will be getting cancelled and we are having r square is equal to 3, which implies if we take the square root of both the sides, we will be getting r's value as plus minus square root of 3. Okay, possible values. The question suggests that we will be getting multiple values of r. Indeed, we are having multiple values of r, which is one of them is plus root 3 and the second one is negative root 3. Okay. Coming to the last subpart E, given that V99, the 99th term of this geometric sequence is less than 0. It is a negative number. Find V5, that is the 5th term of this geometric sequence. Okay, fine. So, we are having more than one value for R. Which value of R should we be taking? We do not know what is the value of V1. We know the value of V4. So, if we multiply R with the V4's value, we will be getting V5. That is fair enough. But which value of R should we be taking? They have given us this information that V99 is less than 0. V99 can be less than 0. If we take R as a positive number, if R is equal to positive root 3, and if the V1 is negative, then we will be getting V99 as negative. But can it happen? Let us see. Can we have the first term of this geometric sequence as a negative number? Let's check. Okay. So first, I'm taking case 1. R equal to positive root 3. Okay. And we are seeing the V2 value is 5. Since V2 equal to V1R equal to 5 greater than 0, 5 is obviously greater than 0. It is a positive number and R1 is a positive number. So therefore, V1 times root 3 equal to 5, or V1 equal to 5 over root 3. Therefore, V1, the first term, is a positive number. Okay, when R is a positive number, R is having the positive value, we are seeing the first term is also positive. Therefore, every term is greater than 0. Because V1 is positive, R is positive. R raised to whatever power it may be, it will be a positive number. Multiplied by V1, which is again a positive number, will be giving us a positive number. So, every term of this geometric sequence will be a positive number greater than 0. But we are said that V99 is less than 0. So, we cannot take this R value as a positive number. Okay. So, case 2. R equal to negative root 3 and V2 equal to V1 R, and which is equal to V1 times negative root 3, which is equal to 5. Therefore, V1 is equal to negative 5 over root 3. That means V1 is less than 0. Okay. So, V1 is less than 0, V2 will be positive because V1 is negative and R is negative. So, now that we know which value of R to be taken, we can find the value of V5. V5 should be equal to V4 times R, and V4 is nothing but 15. So, 15 times negative root 3, which is equal to 15 root 3. Okay. And it should have a negative sign in front, of course. It is negative 15 root 3. Okay. So, students, we have solved this question completely. Thank you for watching. I am Nilanjana Sanyal. I am an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. In case you're liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching these videos. And please subscribe to my YouTube channel in case you have not subscribed to my channel till now. It will be motivating me to make more math videos for you. I'll be knowing that I am being able to help you. That will be my motivation. In case you are having any questions, any doubts, please feel free to write to me in the comment section. I'll be trying to solve your doubts, your confusions as much as possible. And we meet again very soon in our next session. We'll be solving the next question of the same paper. Till then, bye.